All right, guys, so this video is part 2 of solving inequalities involving a quotient, okay? So if you haven't seen the first part, I suggest going back and watching that one first, okay? That problem's a little simpler than problem C here is going to be. I copied and pasted this table of steps for you so you don't have to search back through your notes or anything like that, okay? So first thing, you want to move all terms to one side, all right? It doesn't matter what side you move everything to. Our intervals are going to be the same. Our solutions are going to be the same. It's just your steps might be a little different than mine. Not much, but just a little bit. Okay? So I'm going to move everything to the left side. Okay? So when I move this 2 over x minus 1 to the left side, it becomes negative. Okay? So the next thing I want to do, we've got a quotient, so I want to bring these two terms to a common denominator. So my common denominator is going to be x minus 1. So I'm going to multiply that first term x by x minus 1 over x minus 1, okay? So when I do that, what I end up with in my numerator is a quadratic expression, and that's okay, not a big deal. So we've got x squared minus x over x minus 1 minus 2 over x minus 1, and that's less than 0, okay? So I can combine these numerators. There's no like terms up there, so I'm just going to kind of push everything together into a quadratic trinomial. And I get x squared minus x minus 2 over x minus 1 is less than 0, okay? So that's all step 1, okay? Getting everything on the left side in this case and getting a common denominator, okay? Now then, in the previous video, there wasn't anything to factor. In this video, there is something to factor. So I'm going to factor that numerator, and that's going to be x minus 2 times x plus 1, all right? So now then, next step, we're going to find the intervals. We want to think about what makes each of these three factors equal to 0, okay? So x minus 2, if I were to plug in 2 for x, I would get a 0, okay? So that's going to be part of the intervals I'm going to form here in just a second. If I plug in negative 1 to this binomial, I get a 0 there. And down here, if I plug in positive 1, I get a 0, okay? So these are the values that make this expression, either the numerator or the denominator, 0, okay? So those are going to be the ones that I'm going to use to help me form my intervals, okay? Now then, notice my table has gotten a little bit bigger here because in the previous problems, I only had 2 values here to help me form my intervals. Here I've got 3, so I actually need another column over here to deal with, okay? I actually need another row too because I had 3 factors I was dealing with, not just 2 like in the previous problems, okay? So the smallest of these 3 values is negative 1. So my first interval is going to go from negative infinity to negative 1, okay? The second smallest number here is positive 1, so I'm going to have an interval from negative 1 to positive 1, and the next value there is 2, so I need an interval from 1 to 2. And then my final interval will be from 2 to positive infinity, okay? So those are going to go on my top row in my table, okay? Down this first column here, this left-hand column, I'm going to put, we need to find the sign of that binomial, x minus 2. We need to find the sign of that binomial, x plus 1. We need to find the sign of the denominator, x minus 1. And then I need to determine the sign of that whole expression. So x minus 2, x plus 1 over x minus 1, okay? So just like before, we're going to find the signs when we plug in test values that are within each of these intervals, okay? So from negative infinity to negative 1, we could just pick negative 2, for example. So negative 2 minus 2, well, that's going to be a negative value. I don't care that it's negative 4. It's irrelevant. I just want the sign. Okay. In this interval, a number easy to work with is 0. So 0 minus 2 is also going to be negative. A number between 1 and 2, like 1.5. So 1.5 minus 2 would be negative. And then if I plug in a number between 2 and infinity, like 3, 3 minus 2 is a positive value. Okay. So let's do the same thing for each of these factors. So plug in a negative 2. Negative 2 plus 1 is negative. Plug in 0. 0 plus 1 is positive. Plug in 1.5. 1.5 plus 1 is positive. And plug in 3. 3 plus 1 is positive. Okay? All right, last one. In this interval, let's use -2. So -2 minus 1, that's going to be negative. Plug in 0 for this interval. 0 minus 1 is negative. Plug in 1.5 for this interval. 1.5 minus 1 is positive. And plug in 3 for this interval. 3 minus 1 is positive. Okay? So now we've got everything we need for the entire quotient here, for this entire expression. I've got a negative times a negative divided by a negative. So I've got an odd number of negative signs there, which makes the entire quotient negative. Okay? Let's look back at where we are. That's what I want. I want it to be less than 0. Okay? So that's going to be part of my solution. Okay? In the second interval, I've got an even number of negatives. I've got 2 negative signs and a positive. That means the entire quotient will have a positive value. That's not what I want. I wanted it to be negative. So this is not part of my solution set. Here, I've got an odd number of negatives. That makes the entire quotient negative, which means that interval is part of my solution. Okay? And then the last interval, they're all positive. That means the entire quotient is positive, so this interval will not be part of my solution. Okay? So the solution set then is going to be the union of these two intervals. It's going to be the interval from -infinity to -1 and the interval from 1 to 2. Okay? Now notice I've got parentheses for each of these. That means -1 can't be included in the solution set. 1 is not included in the solution set, and neither is 2. Okay? Infinity is not a number. Okay? It's a concept. So that will always be preceded by, -infinity would always be preceded by parentheses. Okay? Now let's look back at the quotient that we ended up with here. If I plug in +2 or -1, okay? If I plug in +2 or -1, they make the expression equal to 0. 0 is not included because the inequality symbol just says less than, okay? So -1 and +2 are omitted from the solution set because they make the expression 0. +1 is excluded because it makes the expression undefined. 1 makes the denominator at every turn 0, and that can't happen, okay? Division by 0 is undefined, okay? So for different reasons, all 3 of these values are omitted from the solution set, okay? So that's how you solve inequalities involving quotients.